some examples of exponents with solving with properties. So in this case, A, we have 3 to the power of negative 2. We gotta realize there's negative exponents. We don't tend to enjoy having negative exponents. So let's convert to a positive exponent. So convert to a positive exponent, that implies we're gonna do the reciprocal. 1 over 3 in other words. We always put a 1 underneath whenever we don't have any other numbers being multiplied to that particular 3 in this case. So that means that we have 1 over 3 that convert our exponents into a positive. You flip fraction. So you convert into a fraction, 3 to the negative 2 over 1, and then flip it. But remember, that 1 always stays on top. Agreed? It doesn't change. So 1 over 3 squared, right? And that's a positive 2. So that means 3 squared is 3 times 3. So 1 over 3 times 3. The number repeats twice according to the exponent. That's what it tells us. 3 times 3 gives us 9. So 1/9 would be our final answer for this case. So 3 to the negative 2 is equivalent to saying 1/9. So remember, you can check with your calculator real quick, right? So real quick calculator check. Try on your calculator, clear anything you might have. In this case, 3, caret key, to say it's an exponent, open parentheses. Put a negative sign. It must be a negative sign right next to your enter button at the very bottom. Do not put the subtraction. It has to be a negative sign. So negative 2 is your power. Close your parentheses, hit enter, and that'll give you the decimal value, 0.1111. And take 1 divided by 9, which is our final answer supposedly, and check that they are the same. Yes, they're the same. So therefore we got the correct answer. 3 to the negative 2 is equivalent to 1/9. Let's proceed with the next one. And circle our answer, right? So going on for the next one, B. T to the negative 8. Once again, in this case, we gotta realize that it has a negative exponent. So we want to convert to a positive, meaning we gotta take the reciprocal, put 1 on top, and we're gonna put underneath the fraction sign, 1 over something, right? 1 over t. And let's not forget to include the 8. It becomes positive, right? But do notice, the 1, it was always there, agreed? We haven't changed the 1. It's still a positive 1. It's still the same 1 from the beginning. We just show it, that way we can bring down the t. So there's our positive 8 now. 1 over t to the 8. Well, t to the 8, we can't simplify in this case because we don't know the value of t. So, but now if I told you t was 100, you'd be able to put 1 over 100 to the 8th and simplify it much easier. So for now, let's just say that's our most simplified answer. We can't simplify any further. Here's the reason why I put an arrow rather than an equal sign. I recommend you work this one down instead, but just for reference, I'm showing you how to work it to the side. Do notice, once again, no equal sign would be preferred. Otherwise, we may think later on that we need to solve it, agreed? But we don't want to solve, since it's just an expression. There was no equal sign from the beginning. Once again, notice the 8 is an exponent. You want to make it small and higher than your regular numbers. Otherwise, you're going to confuse it with a multiplication and think you're going t times 8. So be aware of that. So let's go for the next one. C. Okay, for C, we have a to the third divided by 5 times b to the negative 6. And on the outside of the parentheses, we have a square. So we can't simplify in the parentheses. We gotta always try to simplify in the parentheses if possible. A to the third, well, we can't combine any other terms, agreed? So no terms can be combined in this case or simplified. We can't simplify fractions. So that means we gotta distribute the exponent of 2. Distributing the exponent of the 2 to a to the third gives us 3 times 2. So a to the 3 times 2. And distributing the 2 to the 5 gives us 5 squared. Distributing the 2 to the 6 also, well, pardon me, b to the negative 6, I should have said, gives us b to the negative 6 times 2. Okay, so let's simplify this. A to the 3 times 2 gives us 3 times 2 is 6. 5 squared, 5 times 5 is 25. There we go. Negative 6 times 2 gives us negative 12. Oh great, there's a negative there. So we gotta simplify one more step, right? Oh, not a big deal. Remember, change the location of the b. If it was a negative on top, well, I should say a base with a negative exponent on the top of the fraction sign, we would bring it down. But since it's on the bottom, we're going to bring it up. Now the question is, does a have a negative exponent? Does the 25 have a negative exponent? No. So a and 25 do not have negative exponents. So a to the 6 and the 25, we leave them in the location where they currently are. It's the b that has the negative exponent. B is the base, right? So the base of b has a negative exponent. To make it a positive exponent, we bring it to the top, and it becomes a positive exponent now. So there's our final answer. We got a positive exponent. So a to the 6 times b to the 12 divided by 25. It's fully simplified now. Let's be aware of this. A power expression is simplified if 1. It includes no parentheses. 2. In any monomial which variable constants appears a base at most once. 3. Each numerical expression has been calculated, each numerical fraction has been simplified. And 4. Each exponent is positive. Let's start with step 1. It includes no parentheses. So look at your answers. 1/9, no parentheses. 1 over 2 to the 8, no parentheses. A to the 6 times b to the 12 over 25, no parentheses. In any monomial, that means a single term. Each variable or constant appears a base at most once. So variables are constants. 1/9 shows up once. 1 over 2 to the 8. T is a variable, shows up once, right? Up next to the last one, C. A shows up once. B shows up once. And 25 shows up once. So 3. Each numerical expression has been calculated. Each numerical fraction has been simplified. 1/9, well, we can't simplify any further unless we get a decimal. And that's as simplified as it gets for exact values. 1 over 2 to the 8, can't simplify any further. There's no numbers, right, other than the 1. A to the 6, b to the 12 over 25, we can call it 1/25, since we can put a 1 in front of that a, right? But we wouldn't be able to simplify. And 4, step 4, each exponent is positive. None of them have negative exponents for the circled answers, I should say, right? So the ones that we circled have no negative exponents. So it means we completed this correctly. We have finished solving in this case, agreed? The power expressions are simplified for this particular case. And there are our final answers.